Hello and welcome! In this video I want to show you how to factor a polynomial using the rational roots theorem along with synthetic division. Now to help out this process I'll probably also use a couple of other theorems as well just to help narrow down the list. So let me give you a summary of how this will work. First I'm going to use that rational roots theorem to basically come up with a list of possible zeros for the polynomial. Now once I do that I'm going to use synthetic division to start testing these zeros out one at a time. Now as I'm testing these things out, I may use Descartes' rule of sign to also help narrow that list down so I can just basically do the process faster. Alright? So the first thing I need to come up with is basically a list of possible zeros. Alright, so to come up with this list of possible rational zeros, you want to take your factors of the last term, this is the 108, and divide it by the factors of the first term. I like to call these the P over Q. Okay? So let's list out all the factors of 108, and they're going to all be divided by 1. Basically plus minus 1, plus minus 2, I got 3, 4, 6, 9, 12, 18, 27, 36, 54, and 108. Wow. So I have quite a bit of possible rational zeros that I might have in my polynomial, and basically we have to test these out one at a time. Now since I do have so many, I kind of want to use Descartes' rule of sign here so I can see how many I can expect will probably be positive and how many are going to be negative. Let's go ahead and take a look at that process. So to get an idea of the possible positive zeros I might have, Descartes' rule of sign says that I can count the sign changes in the polynomial and get an idea. So here's that polynomial. Let's see how many times it changes sign. So it goes from positive to negative. And it goes from negative to positive, and then positive to negative. So in terms of how many possible positive zeros could I have? Well, I could have 3, or I could have 1. Okay, not too bad. To figure out the possible negative zeros, we look at f of negative x. So I put in a negative x for all of my x's, then we'll simplify this, and then count the sign changes one more time. Let's see, this will be x to the 4th. Let's see, minus x to the 3rd, and there's already another minus sign, so 5x to the 3rd. Let's see, minus 9x squared, minus 81x, minus 108. Perfect. So as I look through this, it looks like that we only have one sign change here, so there's probably only one possible negative zero. Now remember that since this is a 4th degree polynomial, I'm looking for 4 total. So what these possible things tell me is that I could have 3 that are positive and 1 negative, or I could have 1 positive, 1 negative, and 2 complex. Alright, let's go ahead and set that information off to the side and see if we can start testing out some of these zeros one at a time. So with so many zeros to test, usually I start off with the smaller guys first. Synthetic division is definitely the way to go here because it's the fastest way to test out a zero. Alright? So what we're going to do is basically take these guys one at a time. In synthetic division, we take the 1, drop it down just as it is. We multiply, then we add, multiply, add, multiply. See, now I need to add these two together. It's like a 68, multiply, and this will give me a negative 40. Now what I'm doing every time I test out one of these zeros is you always want to check out your remainder to see if you get a zero remainder. If you do, you know you found a zero. In this case, where we got a negative 40, I know it's not one of our zeros. So then you can go back to your list and say, all right, that positive 1 did not work. Let's cross it off and test something else. Well, since that one didn't work, I'm going to go on and try and, let's use a 2. Alright, so bring down the 1, multiply, add, multiply, let's see, add, multiply, add, multiply, and add. Alright, so it looks like this one's no good as well. Well, let's keep going. And we'll test out a 3. Bring down the 1, multiply, add, multiply, add, multiply. Let's see, negative 45. There we go. Add these two together. Multiply. And add. Hey, what do you know? So it looks like 3 is definitely one of our zeros. So I want to go ahead and circle that guy and say, yep, we found one. And also go back to my list and say, okay, well, it looks like the positive 2 didn't work, but the 3 did. Now, we don't necessarily want to keep going on to the 4, because the only way we cross something off the list is if something doesn't work. So if I know that 3 works, I'm actually going to try it again, and I'm going to try it in the reduced numbers down here. Now also when looking at the reduced polynomial for here, notice how that my term is now 36 on the end. This means that I don't have quite as many factors to consider as I did the first time. Anyway, let's go ahead and test out the 3 and give it a shot. So let's see, drop it down, multiply, add, multiply, add, and multiply. What do you know? It looks like the 3 worked again. Let's keep it. And now look at our reduced polynomial. You always want to kind of keep an eye on this polynomial as you do find your zeros, because it gets smaller when you do find some of the factors. For example, when we start at the very beginning, we had an x to the 4th. So this is like a little x to the 4th here. But when we found this first zero, we reduced it to an x cubed. Then we used that reduced polynomial and we found another zero, so now this is an x squared. Now what that tells me, as soon as I get down to an x squared, is that maybe I can just factor this and find my last 2 zeros. And sure enough, looks like this guy does factor. Let's see, this will factor into x, x. Then I got a plus 4 and a minus 3. Which means my last 2 zeros, I have a minus 4, looks like 3 again. Well, notice how this fits pretty good with my possibilities. I have 1, 2, 3 positive zeros and 1 negative. That's one of the possibilities Descartes' rule of signs said we'd come across, that 3 of them are positive and 1 is negative. So alright, we know we're on the right track here. Let's go ahead and list out all the zeros we found. And from these, we want to build the factors. The factors are always x minus the 0. So I have x minus 3, x minus 3, x minus 3, and an x plus 4. Well, really, since all of these are the same, I could write it as x minus 3 cubed times an x plus 4. There we go. So when taking that original polynomial, this is what it factors into. And there you go. So you can see those theorems help out a lot, but even with the extra theorems, sometimes you really just have to use the synthetic division and really just start hammering these things out one at a time. If you'd like to see some more videos, please visit mysecretmathtutor.com.